again to today's class on integration. We want to solve some problems on integration, but before then we want to recall to ourselves that integration is simply a process of getting antiderivative of a function. That means it's an opposite to what? Differentiation. That is, in calculus, differentiation and integration, they are always an opposite. Okay? Now, in solving integration problem, there are methods one can follow to solve it, and one of it is substitution method, integration by parts, integration by partial fractions, and integration by trigonometry. For substitution method and integration by parts, you must see that you have a what? A product function. There must be a product function before you embark on integration by substitution or by parts. But what will help you to know if you are using integration by parts or if you are using integration by substitution is when you differentiate the first function or when you differentiate one of the function. If there is one of the function you are to differentiate and you invert it and is able to cancel the second one, it means use substitution method. Take for instance, differentiate this, you will be having 2x. Invert it, you have this. Can it cancel exponential 2x? You say no. Differentiate this, you will be having 2 exponential 2x. If you want to know how we are doing this, check videos we have uploaded on my channel. We have explained this, but let me explain it again. Differentiate this, that means the power times coefficient. 1 times 2, 2. 2 minus 1, 1. You have 2s1. Invert it. Check whether it will cancel exponential 2s. Can this cancel this? No, not possible, because exponential 2s and 2s are not the same. Then you now say, let you do the other way around. This one, differentiate it. Differentiate 2s, you have 2. Then attach exponential 2s to it. That is how to differentiate this. Then invert it, you have this 1 over. Then times x squared. Can x squared cancel a 2 exponential 2x? No, because they are not the same. So you will not use substitution method. You will go for integration by parts. Now, I do not want to waste time while integrating this. I will use a simpler method to integrate it. Instead of using integration by part, I will use a simpler method. That means you can use integration by part to solve it, and you can also use this method I will use. Look at the method. Write D, write I. This is differentiation and integration. How do you know which will be here? Check which of these two functions can you differentiate and you get 0. I will write x squared, differentiate it 2x, differentiate it 2, differentiate it 0. It means this is best to be on D part. Here, integrate, I will have this. Integrate this, that means differentiate 2x, you have 2. Invert it, 1 over 2, exponential 2s. I've integrated this. I will now write 1 over 2 exponential 2s. That means what I am to write is exponential 2x all over 2. Then I have to integrate it again. This means 1 over 2 times differentiate. To integrate exponential 2x over 2, I'll write 1 over 2. Then integrate this. To integrate exponential 2x, differentiate 2x, 2. Invert it, 1 over 2. Then attach exponential 2x. That will be giving me exponential 2x over 4. I will write exponential 2x over 4. I'm to integrate this answer again to get what I will write here. That means 1 over 4 times, integrate this, that is exponential 2x. That will be giving 1 over 2 exponential 2x. That will be giving me 1 over 8 exponential 2x. Exponential 2x over 8. I will now put plus, minus, plus, minus. This signs goes at this order. Plus, first plus, next minus, next plus, next minus. Continue that pattern. Then I will put it this way, put it this way, put it this way. This times this is 0, okay? So I will multiply this in diagonal method. This times this will be giving me x squared exponential 2x all over 2. This times this, 2 times 2x times this will be giving me minus 2x exponential 2x all over 4. 2 times this plus 2 exponential 2x all over 8 plus c. Reducing to its lowest term, okay, you will be having it to be x squared exponential 2x all over 2 minus x exponential 2x all over 2 plus exponential 2x all over 4 plus c. So this is the answer you will get when you use the shorter method. Why I decided to use this shorter method is that if I solve it using integration by parts, I will get this. And integration by parts is integral u dv equal to u v minus integral v du. When I solve it using this pattern, I will get the same answer. But the issue is that it will take you a longer time than this. So this is integration by parts formula, but this is reduction method formula, so that it will be easier for you. Then we go to the next question and want to use this shorter method. We say that this simply means integral 1 over 2 sec square x dx. That is what they mean. So what we will put on the differentiation part is, we will put di. On differentiation part we will put 1 over 2. On integration part we will put sec squared x. Okay, since in differentiate 1 over 2, you have 0 because 1 over 2 is a number. Then integrate this. Differentiation of tan x, differentiate it. The y dx of tan x is equal to sec squared x. That means that when you integrate sec squared x, you get tan x. So integrate this, I will have tan x. So what I will now do is that I will put plus, minus and stop, because here is where I have 0. Then this times this will be giving me 1 over 2 tan x plus c. Why I'm putting plus c is because there is no upper and lower limit given in the question. But if there is upper and lower limit, you put the value of your upper as the value of x, get the answer first, put the value of the lower limit. Like let's say they say here is a and here is b. In this question, let's say here is a and here is b. The implication is that 1 over 2 tan, put your upper limit a, minus 1 over 2 tan, put your lower limit b. You have it like this. So you will not be putting plus c. But because there is no upper and lower limit, we attach plus c in our answer. Thank you once again for joining today's class.